So in the following videos, we're going to solve two triangles that are not right triangles using SOHCAHTOA and by drawing our own altitudes. This is a lead-in for law of sines, which will be the second part or the part 2 video of this. But if we drop an altitude, anytime we want, we can drop an altitude. And I want to find x and y in this triangle. I'm going to start by trying to find x. If I do this, I can drop an altitude and I can just call it random letter h. Now I've created a 90-degree triangle using x, y, and this developed point here, which I'll call capital A. And I can say sine of 33 degrees is equal to h over 14. On the other side, I have another triangle with h and x, and I can say sine of 47 is equal to h over x. Well, solving both of these equations for h, I can get 14 sine 33 equals h, and I can get x sine 47 equals h. H equals h, so I can write 14 sine 33 equals x sine 47. And by making two different triangles and using the common leg h, I can find x here. I have one equation with one unknown, x. And I can do that then by dividing by sine 47 on both sides. But instead of doing that right away, and if I do that, I get x equals 10.4. But I can also divide by 14x on both sides. I can do anything I want as long as I do it to all terms on both sides. And the thing I want you to notice is if I do that, obviously those cancel and the 14s cancel. I get sine 33 over x and sine 47 over 14. And you catch that 33 and x are one pair, and 14 and 47 are another pair. I could solve for y, doing the same thing, dropping another altitude and calculating. But again, the pattern here I want you to catch is that the angle and the opposite leg that relates to it can be set up here. And I can solve for the unknown variable x. If we have another problem like this, where I have triangle PRE, I can do the same thing here. I can drop an altitude. And I can set up h. And again, sine 45 would equal h over e. Two unknowns, so I can't solve for it, but it works there. And likewise, I can use the second triangle here and say sine 63 equals h over 22. Again, solving for h, I can put the e with the sine 45, and I can put the 22 with the sine 63, and I can set those two equal, and say e sine 45 equals 22 sine 63. Divide both sides by 22e, which would get rid of the e and put a 22 on the bottom. And on the other side, we get rid of the 22 and get a e on the bottom. And again, what I'm interested in you noticing right now is that the 45 degrees and the 22 are together. 63 degrees and the e are together. Again, we now cross multiply and divide. I can get 22 sine 63 divided by sine 45 equals e. I can call up my calculator here and type that in here. 22 times 63 sine is 19.6 divided by 0.7. We get 27.7 for E. And again, we have a pattern here. This pattern occurs every time. Every triangle can have this drawn. And if we do it in terms of A and B and C, we can get the law of sines. And that's the next video we'll record, is the recording of the deriving of law of sines and a couple of examples.